Okay, so let's solve another problem which is similar to 1032. So this is 1033 in your book. There is a small difference between the previous problem and this problem. Let me read it out. The golfer wants to hit the ball the same horizontal distance of 130 meters and 20 meters above his tee-off point as in problem 1032. But in this case, the tee-off point is 10 meters above the landing spot of the ball. What is the ball's initial velocity? So the tee-off point is 10 meters above the landing spot of the ball. So let's see. Let me draw this picture or this diagram. And so that is 20 meters, and let me call these points A, B, C, D. Okay. So this is where the ball lands, and this is the initial spot from which it is hit is 10 meters above, so this is 10 meters. Okay. And this is 130 up to here. Okay. All right. So let's see what the initial velocity is. Now, as mentioned before, the initial velocity u has two components. It has two components, ux and uy. Uy goes from whatever it is at this point, which is uy, to 0 at this point, right? And then back to uy here, and then it keeps on increasing up to this point. Okay. Right, so let's go about it. Let's look at the vertical. Usually the vertical is the part of the problem, the vertical part of the journey of the problem is the one that you get some information from, which you go back and use in the horizontal journey of the problem. Okay, so let me write vertical here. Okay, so in the vertical you have, it has covered, so we're talking about the first leg of the journey, so going from here all the way to here. Okay, so it has gone vertically, it has gone 20 meters up. Okay, irrespective of the path, the displacement, vertical displacement is 20 meters. Okay, so I'll write sy is 20 meters. Okay, initial velocity we don't know, right? Final velocity is final vertical velocity is 0. Initial vertical velocity we don't know. Okay, of course we know the acceleration. Okay, so let's go about it. We'll use our formula. V square minus u square is 2as, in this case 2gs. So and here, because I'm going to make everything y, okay, so this is 0 square minus u y square equals 2 negative 9.81 meters per second square times 20. So uy is equal to, let's do that. So square root of 40 times 9. So you get 19.81 meters per second. Okay, so now you know the initial velocity, the final velocity. We can also find the time. So let's go ahead and get that out of the way too. Okay, v minus u is equal to at. Okay, so t is equal to v minus u over a. So now converting, because this is all vertical, I'm going to put the subscripts here. So 0 minus 19.81 divided by acceleration, which is negative 9.81. So 19.81 divided by 9.81, 2.02 seconds. 2.02 seconds to go from point A to point B. What else? From here we can also calculate the horizontal velocity if we want, right here. Okay, which is what we can say. Let's hang on to that part. Let's wait for that part. Let's look at let's continue with the vertical and find what's going on with when the ball reaches point D, right? When the ball reaches point D, which is 30 meters from point B. Okay, so now pay attention here. So from B to where it finally falls D, this is 30. So finally it has fallen 30. It has fallen 30 meters from point B to point D. So from this we can obtain the velocity at D. Okay, we can obtain the velocity at D, and from there we can get the time it takes from B to D. Okay, same way as from A to B, we calculated the velocity, and then we calculated how much time it took, and then from B to D we're going to calculate the velocity and the time it took, and we're going to use the same set of formulas. Okay, so let me write here, from B to D, from B to D, S Y, let's say BD. Okay, if you don't want to write BD, that's fine, as long as you know that this distance is different, then that's fine. Okay, and then the vertical, the initial velocity here is 0, right? When it is falling from here, what did I say? From A to B, the vertical velocity decreases until it becomes 0 at B, and then from B to D it keeps on increasing. Okay, so the initial velocity at B is 0. Okay, final velocity is, we don't know, we gotta find. Of course, acceleration is 9.81 meter per second square, as always. So v square minus u square is 2as v square, so all of these are y, and then they're also so I'm just gonna say final velocity at D instead of initial velocity BD. Maybe I'll just call it B, because this is the initial velocity starting from B, right? Now it's going from B, this is C, and this is D. So initial velocity here, so I'm going to call it U. We want vertical velocity at B, so here it is the final velocity vertical at D. Okay, let's do that. That might be a little better to differentiate. Okay, sy, I'll say bd. And even if you don't write the subscripts, as long as you know what they are, that's fine. This is 0 is 2 times 9.81 times 30. So v is square root of so that comes to 24.25 meters per second VYD. Okay. So when the ball hits here, its velocity is this much. Okay. Now we know the initial final velocity, we can find the time. Okay. So let's find the time. V minus u equals at. So I'm not gonna work. Okay, let's go ahead and put the subscripts d yb. So 24.25 minus 0 is equal to t, and divide by 9.81. So 24.25 divided by 9.81 is 2.47 seconds. So what should we call this t? Call this bd. That means from b to d. So the t from this t is from, this is t from a to b. Okay, so from a to b it took 2.02, b to d it took 2.47. So total time, total time is TAB plus TBD is 2.02 plus 2.47. That's equal to 4.49 seconds. Okay. So in 4.49 seconds, and now you must, it'll make sense to you why we were trying to calculate the time. We want to calculate the time because in this time, right, this time plus this time from here to here, it has covered horizontal distance of 130 meters. So that'll give us in the velocity in the horizontal direction. Okay, so 4.49 seconds to cover 130 meters horizontal direction, right, or x direction. Okay, so we know time, we know the distance, s equals ut. There is no acceleration because what did we say? The horizontal velocity component of the velocity remains the same throughout, doesn't decrease, doesn't increase. So the plus half at squared, that becomes 0. Okay, let me just write it down for, right, that whole thing becomes 0 because acceleration is 0. Okay, so 130 is ux times 4.49. so ux is 130 divided by 4.49. so ux is let's see, 130 divided by 4.49, 130 divided by 4.49, 28.95, 28.95 meters per second. Okay, so we know ux is 28.95 meters per second. This is ux, this is uy, which we got here, which was 24.25. So the resultant u is square root of 24. Sorry guys, the vertical velocity is not 24.25. The initial velocity is 19.81. So this is the one I should highlight. Okay. The initial velocity in y direction is 19.81, and the initial velocity in the x direction is 28.95. So 19.81. Okay, so 28.95 square plus 19.81 square. So u is equal to 35.073 meters per second. Okay, so 35.073 meters per second, angle theta is equal to tan inverse of vertical component 19.81 divided by 28.95. that comes to 34.37 degrees. Okay, all right, so let's recap. What did we do? The question is, a ball is hit with some initial velocity. It reaches a maximum height of 20 meters. It is let to fall 10 meters below its below the starting point, 10 meters below the starting point, and the total horizontal distance it covers is 130 meters. So what do we do from this initial part of the from this initial leg of this journey? We calculate the velocities, we calculate the final velocity, we calculate the initial velocity and the initial x velocity, initial y velocity, and the time. Okay, initial y velocity, and we also calculate the time it takes to get there. We do the same thing on this side. We calculate the time it takes to go 30 meters. So it travels 30 meters and it travels this horizontal distance. Okay, but we cannot say this is half, because in this case, see that part, so that is out of the symmetric part. This and this are symmetric, but then there's some extra part, so we cannot say from here to here is half of 130. Okay, so anyway, from B to D we calculate the final velocity. Okay, from B to D we calculate the from B to D we calculate the final velocity. From the final velocity we calculate the time. Okay, so we calculate the time, and then we say, well, we have the time on this end, this much. We have the time it goes from B to D, and we now also had the time from A to B. So total time and the total distance it covers in that much time is 130 meters. So 130 meters, and we know the time, so we can find the velocity. We can find the horizontal part of the velocity, which we got here. So from the first leg of the journey from A to B, we know the initial vertical velocity, and here we know the initial horizontal velocity. So you combine those two vectorially, you get the resultant initial velocity, and then we can find the angle.